What if a star in our night sky suddenly exploded, not in some distant galaxy, but one we've known all our lives? What if it shone brighter than the full moon, visible even in broad daylight, and cast shadows at midnight? Would it mean danger or discovery? Every night, millions unknowingly stare at Betelgeuse, a glowing red shoulder in Orion's constellation. It seems steady, eternal. But what if I told you it's not just a star, but a ticking cosmic time bomb? Scientists believe Betelgeuse is dying, not in a poetic sense, but literally collapsing from the inside, preparing for a finale that could be visible across our planet. Could we be witnessing the death of a giant, centuries after it actually happened? And if so, what would that moment look like? This isn't science fiction. It's science, right on the edge of spectacle and suspense. And the strangest part? It might have already happened. We're just waiting for the light to reach us. So look up, because the night sky may soon tell a story not of beginnings, but of an ancient ending, finally arriving on time. Betelgeuse isn't just any star. It's a red supergiant, one of the largest and most luminous types of stars in the universe. And that title alone tells us everything we need to know. It's old, it's unstable, and it doesn't have long left. If you replaced our sun with Betelgeuse, its surface would stretch far beyond the orbit of Mars, possibly even reaching Jupiter. That's not just a bigger star, that's a devourer of planets. Mercury, Venus, Earth, and Mars wouldn't just burn, they'd vanish inside its bloated, fiery atmosphere. Betelgeuse is over 700 times the sun's diameter and could fit 1.6 billion suns inside. Yet for all its size, Betelgeuse isn't as heavy as you'd expect. It's only about 10 to 20 times more massive than the sun. Why? Because it's puffed up, bloated and loose, its outer layers stretched thin like a balloon near bursting. This is a sign that it's burning through its final reserves of fuel. It's gone through hydrogen, helium, carbon, climbing the periodic table. Once it hits iron, the party's over. Iron can't be fused for energy. When the fusion stops, gravity wins, and the star collapses in on itself. And when that collapse happens, it won't be silent. It will be one of the most powerful explosions the galaxy has seen, a supernova. A cosmic event so bright it could turn night into day. Scientists aren't guessing if Betelgeuse will explode. Only when? Tomorrow? 100,000 years from now? Or did it already happen centuries ago? We often hear terms like supergiant or massive star and imagine something maybe a few times larger than the sun. But Betelgeuse makes even the boldest comparisons feel small. Let's break it down with perspective. The sun, the most dominant object in our solar system, could fit over 1 million Earths inside. Sounds huge, right? Now picture this. You could fit 1.6 billion suns inside Betelgeuse. If Betelgeuse were placed at the center of our solar system, its outer surface would engulf Mercury, Venus, Earth, Mars, and possibly even reach Jupiter. That's not a solar system anymore. That's a fiery sphere devouring everything in its path. And yet, Betelgeuse isn't even among the heaviest stars. That's like seeing a balloon the size of a skyscraper, but light enough to float. It's stretched out, bloated, and ready to burst. Even more staggering, its explosion, the eventual supernova, will release more energy in seconds than our sun will emit in its entire 10 billion year lifespan. The explosion won't just be big, it will outshine the full moon, visible to the naked eye even during the day. Imagine walking outside at noon and seeing a new star in the sky, casting shadows like a second sun. It won't burn us, it won't harm Earth, but it will change the way we see the universe. Betelgeuse reminds us that space doesn't play by the rules of our everyday experience. It's a place of extremes, and Betelgeuse is living proof of just how far those extremes can go. While Betelgeuse rages silently in deep space, humanity is watching, closely, patiently, and with growing fascination. From mountaintop observatories to billion-dollar space telescopes, we've aimed some of the most advanced instruments ever built at this one dying star. Scientists track its pulses, its flares, its mysterious dimmings. It's not just a cosmic curiosity. It's a rare, real-time laboratory to study stellar death as it happens. When Betelgeuse dimmed dramatically in late 2019, alarms quietly went off in the astronomy world. Telescopes turned, data flowed. The Hubble Space Telescope even captured signs that the star had expelled a huge blob of gas, a sneeze of stellar proportions. It wasn't just poetic, it was measurable, a piece of a star thrown into space. Astronomers scrambled to interpret the signals. Was it internal instability, a drop in surface temperature, or was this the last gasp before collapse? The truth is, no one knows. That's what makes it thrilling and humbling. Every flicker, every shift in brightness is logged, analyzed, debated. We don't know when Betelgeuse will go supernova, but we want to be ready. Ready to record it. Ready to understand it. Ready to witness the death of a star, not in ancient records, but with our own eyes. This is humanity's quiet vigil, a global scientific stakeout, waiting for a star to blink its final light. Imagine this. You step outside on a normal evening. The stars are out. Orion hangs quietly in the winter sky. But then, something's off. There's a new light, brighter than the full moon. It casts shadows. You can read by it. And it's coming from Betelgeuse. It has happened. The supernova has arrived, not in the moment, but as a message from the past. The explosion actually occurred centuries ago, but tonight, the light finally reaches Earth. First, neutrinos hit, ghostly particles passing through your body without a sound. Then hours later, the light show begins, a brilliant flash. The shoulder of Orion becomes a beacon in the sky. Cameras roll, telescopes lock on, news spreads instantly. During the day, the light doesn't fade. You can still see it, like a second sun. At night, it glows so brightly it casts shadows on the ground. For weeks, maybe months, it lingers, slowly dimming as the remnants expand. No danger, no apocalypse, just beauty, awe, and wonder. Children grow up remembering the time the sky lit up. Songs are written, stories told. Humanity, for once, united by the spectacle of a dying star. And when it fades, all that's left is a dark scar in space, a reminder that something colossal once lived there. Every time we look at the night sky, we're looking into history. The stars we see aren't shining now. They were shining hundreds, thousands, even millions of years ago. The light just took that long to reach us. Betelgeuse is no exception. It's 640 light-years away, which means the glow we see tonight left the star in the 1380s, during the medieval era on Earth. When Betelgeuse finally explodes, we won't be witnessing something happening. We'll be catching up with something that's already over. And that's the most humbling part. In a universe this vast, even light can't outrun time. Maybe that's what makes Betelgeuse so powerful. Not its size, not its brightness, but the story it tells. A story of endings, of waiting, of reminders that some of the greatest events in the cosmos unfold long before we ever know they happened. One day, tomorrow or 1,000 years from now, the light from that final blast will reach us. And for a brief moment, the entire planet will look up and see the same thing, together. Until then, Betelgeuse is our cosmic countdown, a glowing ember from the past, flickering in the sky, reminding us that even giants fall. And when they do, their light travels far and lasts forever.